This morning we're going to learn about equivalent fractions, which means equal fractions. They might look a little different, but they have the same amount. And so what I'd like you to do is everything you see here, just copy down the notes, pause the video, copy everything down, and then you're going to listen. And let me fix my O here. Okay, so go ahead and pause and copy the whole thing down. Okay, now we're ready to begin. So I put this EQ here, which means essential question. How can fractions be used to represent numbers and their parts? So we've already kind of learned this, so we're going to look at some models first. So I put some rectangles here, and I divided this one into half, I divided this one into fourths, and I divided this one into eighths. Then I shaded a half, I shaded 2/4, and I shaded 4/8. And what you notice is that even though these are different fractions, they still mean the same amount, because if you look down, they all match up. They're the same amount. So you call 1/2, 2/4, and 4/8 equivalent fractions. Let's look over at our pies. So I divided one pie into 4 parts and the other one into half. So if I shade 1/2 and then I shade 2/4, it's still the same amount of each pie. So you could say that 2/4 is equal to or equivalent to 1/2. We can also use the number line to see this. So if they line up on the number line, that means they're equivalent fractions. So if you look, 1/4 and 2/8 are equal to one another. They're at the same distance from 0. 2/4 and 4/8 are equal to each other because they're the same distance from 0. And 3/4 and 6/8 are equal to one another because they're the same distance on the number line. So we are going to work a little bit more hands-on with these, but I just wanted to give you some background. Good job, guys.